Hello again. This is part 2 of the basic modeling video. This is for the students that missed the first day of class, and it's also a good review for the students that were in class. I'm going to show some tips and tricks that may be helpful. So, continuing from the first video, I purposely shut down Inventor, and that's because I want to show you a different way of opening it rather than using the desktop shortcut or going into the Start menu and then Inventor folder, Inventor Professional. What you can do is go into the files that I had you download from Canvas, Autodesk Inventor 2022 Advanced Part Practice Files. These are the files that actually came with the textbook. The basic modeling part that I had showed you in the first video that we're going to create in this video, I saved it outside of that folder just because it's something that I created. It doesn't have anything to do with the textbook. But everything we're going to be doing, we can just save it in this folder. So in the folder, you'll see some subfolders and several files in the main folder. But only one of those files is a .ipj file type. So if we look at the type column, that file type is Autodesk Inventor Project. Inventor has projects, and it's a way of organizing your data. You can also double-click that project file, and it'll open up Inventor, and it'll set that project as the current project. So that's the benefit of using that file to open Inventor. So if I click New to make a new part, I'm going to use standard IPT. The default part is inches. However, if you go expand that folder, you've got an English folder, standard inch IPT, which is the same as standard IPT. It's just that the default is inches, so they have another template just called standard, but they're identical. If you ever need metric, you just click on the metric folder, and then you're going to do standard millimeter IPT. These other files are for special applications that we're not going to get into. So either the standard inch IPT or in the main folder, just the standard IPT is fine. And then click Create. Notice that the project file is already set to IPJ. The default is what would be set if you didn't do that. If you ever need to change the project, you can use this drop-down menu. But if you've never set the project before, it probably won't be listed there, so you have to click on this Projects button. And then you can switch the project here from default to advanced or any other projects you create. So if you open it from the IPJ file by double-clicking it, it just automatically sets it as the current project. So the benefit of that is a few things, but what I'll mention is the workspace. So if I expand the workspace, right-click on it, and edit, you'll see that it is set to my practice files folder. All right, and that's on my D drive in this case. It might be different for you. I have a folder that I created called TDD227. But wherever you put it, this is your place where you're going to open from and save to. So when you click Save, it's going to go right to that folder. You're not going to have to go hunting around for where you want to save that file. Same thing with opening. Okay, so I'm going to create a new part. Okay, so it puts me in the front view. So I'm actually looking at a 2D plane right now, XY plane. I can use the view cube to rotate that, but I have nothing here yet. I'm going to open up the finished part just so we have it for a reference. So I'm just going to click Open. Notice how it went right to my folder or workspace. For this whole entire class, we're just going to use that one project file. And in here, oh, right. So I mentioned that I saved my file outside of the project. So just in this case, I'm going to go back a folder and then open this file. Now it gives me a warning that I was expecting. It's just warning me that this file is not in the location of the project file. So current project file is advanced part. It's not in that location, but I know that. I purposely didn't save it there because this was just an example to show how to use Inventor. It's not really part of our textbook files. So I'm just going to say yes, that's fine. Continue opening the file, yes. Okay, you can have multiple files open just like in AutoCAD. So you get these tabs down the bottom. So we have part 1. It doesn't have a name yet because I didn't save it. And this is the one I just called basic modeling. And first thing I want to do is just think about how I'm going to create that. And I showed you in the first video, we started with what we're calling the base plate. That's this feature here. And we built that from a 2D sketch. The sketch gets absorbed into the feature. If we ever need to change any dimensions, we can edit the sketch. You know, if I need to change the shape of the profile, or the 8-inch or 3-inch dimension. Or if I need to change the thickness of the extrusion, I can right-click on the feature and edit feature. So there's edit sketch and edit feature, depending on what you need to change. Okay, so where are we going to place this sketch? So if I jump back to my part and I click Start 2D Sketch, right, I must choose one of these 3 planes because that's all I'm given in the beginning. So we can call this XY, YZ, and XZ. Or I often refer to them just as front, top, and right. And you can just see which one's parallel to the view cube faces. So let's look back at the part. I have to be careful if I want this to, you know, I don't want to end up modeling this thing upside down, for instance, or like this. Not that it would hurt, you can always rotate it around to whatever view you want, but I want the default home view to show this face as the front view, which means this face is the top view. So if I click top, you know, that's how I want it to look from the top. So if this base plate is my first feature, and that is parallel to the XZ plane or top plane, you know, that's the plane I want to sketch on. So you're not always sketching on the front plane. In this case, we're going to start a sketch on the top plane. And a shortcut to switching between these tabs is hold the Control key and then press the Tab key. And that switches, you know, between all your tabs. Looks like the getting started was involved in that as well. Okay, so let's click the top plane. Now, based on the settings, it automatically rotates the view so that I'm looking at the top plane. So I'm in a 2D view right now. You can see that over here with the view cube. For some reason, it's 90 degrees rotated clockwise. So I want to make sure I'm oriented correctly because this first sketch always determines how that part is going to sit in 3D space. So I'm going to use these arrows on the view cube just to rotate it 90 degrees so that the word top is upright. So this is the actual top view on the, you know, if I were to make a drawing. This is the orientation of the top view. So since we started a sketch, we get our sketch tools. The sketch tab automatically activates. And we're just going to draw a rectangle. Now it doesn't really matter where I start, you know, as long as I'm on the right plane. The top plane rather. Correct plane, I should say. But you always want to incorporate the origin in it somehow. You could make the origin in the center of the part or one of the corners of the part. In this case, I'm just going to start my rectangle on the origin there. Now I could type in dimensions and it'll add those dimensions automatically. But I'm just going to make it approximately the correct size I want and then just click. Because I prefer to just set the shape first and then I'll go to the dimension command and click that and then add the dimensions after. So I want this 8 by 3. And again, this is a little different than the actual dimensions I used during class. But I tweaked it a little bit. So this will be 3. Okay. Now, if you're not getting that edit dimension pop-up when you place those dimensions, you can just come in and double click on that dimension to change it. But we can also, you might have a setting that we need to change. But the default settings should pop up the dialog box to enter a value. Okay, so we notice that we are constrained to the origin, right? The sketch can't move, and it's fixed in the length and the height. Down on the bottom, we see fully constrained. So I'm just going to finish that sketch. And then it brings me back to a 3D view. If you want, you can actually sketch in that 3D view. So Inventor we have it set so it by default rotates the view, but you can always rotate back and you can work in a 3D view. So you can sketch in this view. Okay, so regardless of when you're sketching, when you're doing your extrusion or any type of 3D feature, so on the 3D model tab, I'm going to extrude this. It means I'm going to take that sketch profile and extrude it in the third dimension. For that, it works best if you're in the isometric view or some 3D view, because then you can see, if you're looking at the top view and you click extrude, it's hard to see. Is it coming out towards me? Is it going in? How thick is it? It says 1 inch, but I can't see the thickness. So always just rotate that if Inventor doesn't do it for you, so you can really get a good preview of what's happening. The default is 1 inch. You can see it's highlighted there, so I can just type in 0.75 for the dimension that I want. And if we need to change anything here, we have options. We can flip the direction. We can go down from the sketch plane up. I can go halfway in each direction. You can do an asymmetric where you get like 0.75 in one direction, different distance in the other direction. But we just need the default option, and default is in the positive direction. So I'll click OK. And now we have our extrusion 1. The sketch gets consumed in there, but I still have access to it if I expand it. Alright, so this is a good time to save the part. And why don't we set a material? Doesn't really matter, this is just for practice. So I'm going to set, how about mild steel? Now notice that, as mentioned in the first video, the appearance automatically changes. So each material has a default appearance. And then if you want, you can override that appearance. But I'll just leave it as steel. Alright, so I'm going to click Save, right? Because I have the project set, it goes right to my workspace as a default location. And as I mentioned before, well, I'll just keep it easy. I'll actually save it in this folder. So we'll call this basic modeling 2, because I already have one. I want to avoid duplicate file names, even though they're in different folders. So I'm going to click Save. Now my file name updates at the top of the screen. And then let's take a look back at this part. So now we need this vertical boss feature. And we notice that the face of the vertical boss is flush with the face of the base plate. So this all becomes one single face. So if I want it to be flush with this face, that's a good face to sketch on. So I'm going to go up here to Start 2D Sketch. And then it's prompting me, select a sketch plane. In the lower left corner, you'll see select plane to create sketch or an existing sketch to edit. So this is our plane. Now, you might think, well, these are the planes. You know, there's our 3 planes we're given. But it's a plane or a face. We can think of each face as an infinite plane. So I'm going to just click that face. Again, it rotates into my view. But like I said, if you want to, you can Shift, hold down the middle mouse button, rotate out of that view. And we could sketch in 3D if we wanted to. So I'm going to click the line command. And again, I'm not going to worry so much about the location or dimensions right now. I'm just going to draw the basic shape, and then I'll add dimensions after. So, I want to constrain this, and if I hover the mouse, you'll see that right next to the X, you'll see the XY coordinates, right? When I hover over this edge, to the left of the X, you'll see that symbol. That's a coincidence symbol, meaning if I left click, it's going to attach it to the bottom edge. It's going to be coincident on that edge. It's sort of like a snap. So I'm just going to start here, coincident, and then go up vertical. Now notice when I get about vertical, I get a perpendicular symbol next to the mouse. And then on the bottom end, you'll see another perpendicular symbol. So that's just telling me if I click now, it'll make it perpendicular. And that's what I want. Now we need to make a arc. So we have an arc tool up here. We also have a circle that we could create and trim. But I'll show you a little trick. So if I drag the mouse back to the endpoint of the line while still in the line tool, and then I hold the left mouse button down and drag away, I get a tangent arc. And then I come down until I get that dotted line showing me that I'm horizontally aligned to the start point, and then let go of my mouse. That'll create an arc. And I can rotate as I'm sketching here. Now if I come straight down, notice I'm getting these different symbols. So there it's showing me I'm going to be perpendicular to the bottom. There I'm getting a parallel. So I'm getting parallel to the left line. Either one will work. Parallel to the left side is the same as perpendicular to the bottom, right? Because they're at 90 degrees. So I want to be coincident. So I want to get that coincident and either the parallel or the perpendicular. So I can see I'm getting both. So I'm just going to click there. And that gives it to me. So I get a preview of all the constraints. So we've got tangent, parallel, vertical. And these are called inferred constraints. I'm automatically getting those constraints as I'm sketching. It picks up the relations to the other geometry. If you ever don't get one of those constraints, you can always add it manually. And to do that, you just go up here to the constraint panel, and you've got things like coincident, parallel, perpendicular, horizontal, vertical, and you just click on the objects to make them whichever type of constraint you want. But we got everything we needed just by inferring them. So that looks good. We just need to dimension it. So while I'm still in the sketch, I'm just going to click dimension. So remember, these tools stay running, so I'm still in the line command. Let's click dimension. And let's make this 2.5 inches from the left edge. So when I click this edge, right, and that gives me the length of the edge, but then if I click this line, oh, I'm sorry, not the line. If I click another object, it'll change the dimension type. So I could either click this center point, or I can click the arc. And let me rotate. I'm going to click front view so you can see this better. What I'm going to do is click the arc. And Inventor is going to know that the arc has a center point. So if I click that arc, it gives me the distance to the center. But I have other options. So if I drag the mouse down here, I get the distance to the left edge of the arc. If I drag the mouse over here, I get the distance to the right edge of the arc. So if you dimension to an arc and you don't click the center point, you click the arc itself, you can get 3 different options. Like the minimum distance, maximum distance, and the center, distance to the center. All from this edge, because that's the edge I clicked. So this is the dimension I want in this case. I'm going to click and put 2.5, enter. And then we're going to have a radius. I think it's 2. Oh, I'm sorry, radius of 1, I'm sorry. Diameter is 2. Radius of 1 there. And then the height. So we're going to do a similar thing for the height as we did for the distance from the edge. I'm going to click the bottom edge and then the arc itself. All right, and that gives me the height to the center. And we'll just put that over here. And it's going to be 2.25. Okay, so we're fully constrained now. Everything changes to one color to show we're constrained. These edges that are yellow, the reason they're yellow is just because they're not something we sketched. They're projected because we referenced them. So when I clicked to make the line coincident to that edge, it just converts that edge into a sketch entity. So they're just yellow, showing that it's attached to that extrusion. It's not something I sketched. So if we alter this extrusion, this yellow edge will move with it, and our sketch will move as well because it's coincident. Okay, so I'm going to finish that sketch, and then what we're going to do is extrude. So another time-saving feature of Inventor, it'll use the last value. So our last extrusion was 0.75. It assumes we want 0.75 for this one. So oftentimes you're using a lot of the same numbers, so that might be helpful. The very first extrusion was always 1 inch. But this doesn't look right, does it? It's in the wrong direction. So we said we wanted the vertical boss to be flush with the end face of the base plate. So I need to flip the direction. So just go over here, click this button for flipped, and it changes the direction. So this blue profile here is flush now, but it still doesn't look right. If I rotate, you can see it better. It's trying to cut away material now. So what's happening is when you have one feature intersecting with another feature, Inventor assumes that you're cutting it, either making a hole or notch or something like that. So that's, incorrect assumption in this case. In some cases it makes things faster. In this case, it's not what we want. So we can change that under output. So over here, the default is join, but it automatically switched it on us to cut. So we'll just switch it back to join, and now it looks correct. So now we can flip the direction again. You can see that better. So because we sketched on this face, we have to go in the -z direction and use the join option. Okay, Okay, distance, we'll also keep that 0.75 and click OK. So notice here that this edge, right, it doesn't continue all the way to the bottom like it did in our sketch. And that's because Inventor merged this whole thing into one solid body. And you'll see this in the solid bodies folder. We'll get into another chapter where we'll have more than one body. But for now, we just have a single body, and that's what Inventor does by default. It just joins everything together. So now we have this one big face. Right? So there's two features here, but they share this face now because they're joined, they're merged. Okay, next thing is the holes. So you saw how we could use extrude to cut. So you could certainly make a circle and cut through, and the result would be a hole. But Inventor has a hole command. So let's make use of that. So click hole, and then all you have to do is click on the face you want the hole, and then click, in this case I'm going to click a linear edge, and then just type in a distance, I think 0.75. Click another edge, 0.75. Do not hit enter at all during this process. If you press enter, it's going to OK the feature, and then we're not going to be able to continue in the same command. So we need two holes that are both a ½ inch. So over here is the diameter. You can see that here. So that's a ½ inch because I had already done this before. You might have to put 0.5 in there. But notice that in the status bar in the lower left corner, it's saying add hole points, then select linear edge or circular edge. So we can continue adding holes if they're going to be on this same face. So notice when I hover the mouse around that this face highlights. Right? That's the face I chose. I can't place holes on any other faces. Nothing's happening there. It doesn't let me click points there. So that's just something to keep in mind. So we're going to put another hole here, and I simply just click, and then it's also 0.5, so that's good. And then we just click an edge to set the distance from the edge, 0.75, and just let it update on its own. Don't press anything. And over here, click this edge and type in 0.75. It'll move on its own. And then once that looks good, then we apply it. So we have 3 holes total. So 2 that are similar. We do all the holes that are same diameter. Actually, I get maybe could be different diameter. But on the same face, all the holes on the same face, we do them. And then you click this plus symbol. So that's apply and create new hole. So I'm going to click that symbol, that button. Now I can choose a different face. And what I'm going to do is my counter bore hole. And that's on this face. So I click the face. And then we need to center it about this arc. So all I have to do is click the arc. And then it automatically centers it at the center point of that arc. So here we needed 2 references. The distance from one edge, distance from the other edge. Here we just need a single entity, the arc, and then it puts it at the center point of the arc. That's enough to fully constrain it, location-wise. So then we just need to set the dimensions. For this, it's going to be a different type of hole. So we've been using just a simple hole, right? Just tell it the diameter and location. There's other types of holes. Clearance hole. That would be where you need to put a bolt, for instance, through the hole, and instead of saying the diameter of the hole, you tell Inventor the diameter of the bolt, and then it makes the hole just a little bit bigger so the bolt can freely slide in and out of the hole. This would be like a bolt and a nut situation. Then you have a tapped hole, which is a threaded hole. You just tell it the size of the threads you need, and then it'll make that hole. with a note on it about the threads. This one, actually haven't used before, so I'll have to look into that one. I have an idea, but I don't want to make any assumptions. But this is still a simple hole. Our counter bore is still a simple hole. There's no threads, there's no clearance, so it's a simple hole. The next option is called the seat. So this is the shape of the hole. We have counter bore, kind of like a countersink, but the depth is perpendicular. So here we get a little diagram, and we can just fill in the values. So for the larger diameter, I'm going to make that 1 inch. And again, don't hit enter. Just type in the values. The depth is 0.25, and then the diameter of the through hole, the hole that goes all the way through, is 0.5. So we've got 1 inch counter bore at a depth of 1/4 inch, and then a 1/2 inch hole all the way through. And just hit OK, because we're done with adding holes. So if you needed to add more holes, you hit the apply, the green plus button. Okay, so you'll see in the model browser, we've got our holes on the top face in one feature. So 2 holes in one feature. And then our second hole, which is a different type of hole on a different face, in a second feature. Okay, next is the fillets. So we're going to do 2 different radii fillets. Come up here to the fillet command, which is right here, next to hole. And then I'm going to set the radius first, and we're going to do a 0.5 on the 4 corners. So I just click these corners. Actually, let me get a better rotation for you. 1, 2, 3. And then the 4th corner, I could rotate the model around because that corner's hidden, right? That edge is hidden. But when you're in the fillet command, it lets you select hidden edges. So if you just hover the mouse, the edge will highlight, and then you can click on it. So it's another time-saving feature. I don't have to rotate it around and click on it. Alright, I also want to fillet these edges along the top face, but they're going to be a different radius. So what I have to do is go into the properties and click the plus symbol, or to have 2 plus signs. This one, add constant radius edge set, and this one is create new fillet feature. So you'll see I have 2 hole features. And you remember I hit that plus symbol to create the second hole feature. In this case, you have an option. The fillet command lets you put 2 different radii fillets in the same feature. So it's called an edge set. Or you can apply that. It'll show up as fillet 1. And then we'll make another set of fillets as fillet 2. I'm going to try to put it all in one feature. And to do that, I'll hit this little green plus button. And then I get a new edge set. And it's telling me select edges, but I'm going to set the radius first to 0.25. And I'm just going to go through and click on those edges. So basically, we want all the edges except for the bottom face and the edges of the holes. Don't forget these little edges right in here. Okay, so that's a 1/4 inch. Notice that the line here, this edge and the tangent and the arc that's tangent, I just clicked on it once. It selected those 3 edges on the front and the back. So when they're tangent, it just selects everything through. On the top, I had to click 1, 2, 3, 4, 5 because this fillet didn't exist yet, so it doesn't recognize that as tangent. So I'm thinking there may be a benefit to doing two separate fillet features. We could take a look at that in class. But for now, this looks good. So what I was getting at is I might be able to save myself some number of clicks. I may have been able to do that in less number of clicks. But this is looking good. So that looks complete. All right. And that is the final model. Let's say we wanted to change something. Let's say I want to push this vertical boss a little bit more towards the center. Well, what I can do is find out where the dimension for that is. Is it in the feature or the sketch? So I know this is the feature, but it's the sketch that actually locates it. The sketch is where it has the dimensions I'm looking for. So I'm going to right-click that sketch, edit sketch, and I can simply just push this over, maybe 3 inches. Finish sketch. The whole feature jumps over. The fillets, everything, whole. So it's all what we call parametric. There's all these relationships that are maintained, and makes things really easy. That's why I said if you're not sure where to start, just start somewhere, and usually it's easy to fix any mistakes or just start over again. All right, and then we'll talk more in class on Friday. Thank you.